We're going to take a look at solving some radical equations. So the trick to radicals, especially the square root kind, is to use squares to solve. So to solve this equation, I'll just rewrite it first. Square root quantity x minus 9 equals 8. And so what we want to do is take the square of both sides. A couple of ways to look at this. Square means multiply by itself, so 8 times 8 is 64. And on the other side, you could say it's the square root times the square root. Or you could just realize that the square and the root are opposite operations and cancel each other out. So in this case, we can take x minus 9 as the result of squaring that root. Now that the root is gone, this is pretty easy to solve. I can just add 9 to each side. And cleaning that up, it looks like x is equal to 73. Now, this is just an educated guess. I think this is the answer based on some rules of algebra I know. I really need to check to make sure. So especially with square root equations, you want to check because every once in a while you can be led astray. So checking in the original, where there was an x, I want to drop in a 73. So we have 73 minus 9 in the root. On the other side, I'm hoping, question mark, this is equal to 8. So 73 take away 9, on a good day that is 64. That means I have to find the square root of 64, and the square root of 64 is 8. So I do get 8 equals 8. It balances, check. That is a solution to the equation above. So I did find one. Let's try another. This one's a bit more difficult. It's got a square root on each side. And so we're going to do a similar trick to before. So rewrite this. 10t plus 5 in the square root is supposed to equal 7t plus 9 in the square root. So just like before, I want to square this side, and to keep things balanced, equal, I have to square, do the same thing to the other side. And if I square a root, they cancel. So that means on the left I have 10t plus 5, and on the right I have 7t plus 9. And so now I just have a linear equation here I can solve. I think I'll subtract the 7t over to the left. That gives me a net value on this side of positive 3t. And then I think I will also, let's take the 5 to the other side. So then I'm going to get a net value of 4 on the other side. And so just double check. I took 7t from each side. On this side I get a 0. On this side I get a 3t. I took 5 from each side. On this side I get a 0. On that side I get a 4. So now I think 3 times t equals 4. So dividing by 3, I think t is 4/3. Now you could plug it into a calculator. You'll get 1.33333. You could make it a mixed number. You would get 1 1/3. So optional answers are 1 1/3, because 3 goes into 4 once with 1 left over. Or it's approximately 1.33 if you check with a calculator. Those 3's keep going on forever, which is a problem. So we can approximate it with a decimal. We can state it as a mixed number or as an improper fraction. I'm going to go with the improper fraction version. And the reason is it's easier to check with an improper fraction plugging back in. So I think I have an answer. Now I have to check. So we need to, where there was a t, we need to plug in the answer we got. And I'm hoping that's equal to square root on the other side, where I'm going to plug in, instead of a t, a number. The number I'm going to plug in is that value of 4/3. Now once I plug in, I'm not doing any algebra, I'm just pretty much doing arithmetic. So I'm just going to draw a line down the middle. 10 times 4/3, I could view that as 10 over 1. That's going to give me 40/3 plus 5 inside the square root. So I usually just work with one side till I'm done. Need a common denominator again, or not again, but in the first place. So call that 5 over 1. Multiply top and bottom by 3 to match this denominator. That gives me 40 and 15 over 3 inside the square root. So what's that? 55 thirds inside the square root. And there's not much more I can do with this without a calculator. So I'm going to see what happens on the other side. On this side, we could say that's 7 over 1. 7 times 4 is 28 thirds plus 9 inside that root. Common denominator here, call that 9 over 1. I'll have to multiply top and bottom by 3. 3 times 9 is 27. 28 plus 27 all over 3 inside that root. It's a square root. 27, that's going to be 40, 55 thirds. Hey, I don't even need my calculator because they match. Check. So that confirms, since I get the same thing on each side when I plugged it in, that t equals 4 thirds is the answer. Circle that again. All right, nice. And you really got to check because sometimes you could be led astray on these. All right, this one's going to be a little bit more work because there's no square root on the other side. You'll see what I mean here once we get into it. The square root of x plus 95 equals x plus 5. And I can square this side, which is going to be nice because that'll cancel the root. On this side, it's not so nice because I really do have to think about this as x plus 5 times x plus 5. On the other side, you could write it as the square root times the square root, but that's kind of irrelevant because when you multiply a square root by itself, the root cancels. So the left side is just x plus 95. The right side requires a little more work. I'm going to have to distribute the x squared plus 5x. Distribute the 5, another 5x plus 25. Got some like terms in the middle. Let's switch out of red here. So I have x squared plus 10x plus 25. That's equal to x plus 95. All right, I think it'd be easier to take these two terms to the left side, so I am going to subtract this x over. So the x's go away, and that's a plus 95, so we'll do a minus 95 on each side. That's gone, so I have 0 is equal to x squared plus 9x plus minus 70. All right, so now I'm praying I can factor this. So let's see, 70, what are the factors of 70? Let's squeeze that over here. And it's negative, so I'm gonna have to subtract. So 1 times 70, 2 times 35, 3, nope, 4, nope, 5 times 14. Oh, we got a winner. Because if I take 14 minus 5, I get 9. All right, so since it's a 1x squared, I'm going to do factor by guessing now. That means I'm going to have an x plus 14 as one factor, and x minus 5 is the other factor. Not done, so that tells me x plus 14 equals 0. Bring it up here. So x plus 14 could be 0. Subtract 14 from each side. And we get x equals negative 14 as one possible answer. Or x minus 5 equals 0. So adding 5 to each side, x equals 5 is another possible answer. So let's circle them and we'll check. So I have two guesses based on some educated work here. I still have to check, and I have to check by plugging into the original. Let's get a new page to do that. All right, so let's check. X equals negative 14. So I'm going to have the square root of negative 14 plus 95 is supposed to equal question mark negative 14 plus 5. And it's always a good idea when you substitute a number in to wrap it with parentheses. So negative 14 plus 95 is, on a good day, 81. So I have the square root of 81 on that side. And remember, we're not doing algebra, just do arithmetic. So you just clean it up. Square root of 81 is 9. Other side, negative 14 plus 5 is negative 9. Oh man, these guys are not equal. So x does not actually equal negative 14. This is what's known as an extraneous solution. So what that means is the negative 14 probably solves one of my intermediate steps here. And I got a lot of steps, right? 1, 2, 3, 4, 5 different steps. So I bet if I plugged in negative 14 into this one, or even this one right here, it might work. But it doesn't work in the original. Okay? That happens in complicated situations like this. Does that mean 5 has to work? 5 might not work either. I got to check. All right, so next, I'm going to check x equals 5. And this one looks like it might work. Got a good feeling. So plug in the 5 plus 95, question mark, does it really equal 5 plus 5? Oops. Let's see, 5 plus 95 is 100. Square root of 100 is 10. Hey, right on. 10 equals 10. Check. All right, so we found that one of the numbers we found does work, the other one does not. So coming back here, I am just going to cross this sucker out. Nope. Not a solution. This one is. All right, you never know. Sometimes you get 1, sometimes you get 2 and one of them will work. Sometimes you get 2 and both of them will work. Sometimes you get a solution and it won't work at all. Rational or radical equations are tricky suckers. All right, ooh, this one has 2 square roots and an extra number. This is one of the hardest ones that you will see, if not the hardest. So, you know, I have a square root all by itself on this side, but not on that side. So that makes it complicated. I can't add the 3 to the 5 because the 5 is in the root and the 3 is not. So I'm kind of stuck. The only thing I can do is square both sides. I'm just going to rewrite this. I have the square root z plus 5, then plus 3. That's equal to the square root of z plus 41. And squaring both sides means you got to wrap the whole side and square it. Wrap the whole side and square it. Now, if we take, let's do the right side first, it's easier. If we take a square root and multiply it by itself, it cancels the root. Here, the addition sign is standing in the way. So I have to view this left side as this thing times itself. So that means I've got a z plus 5 in the root with the plus 3, square root of z plus 5 in the root plus 3. So that's what the left side equals. The right side is the square and the root cancel. That one's super easy. It's just z plus 41. This side's kind of a bummer because now I got a bunch of distributing to do. So first I got to take the square root times itself. That's cool. Square root times itself, the root cancels, leaving me just a z plus 5. And I have to take the square root times 3, which gives me 3 of those square roots. Times plus 5 in the root. Now I'm done with this guy. I got to distribute the 3 here, so I get another 3 square roots of z plus 5, and then 3 times 3 is 9. That's supposed to be equal to that z plus 41. All right, darn, we still have square roots. Oh well, clean it up. Let's see, on the left side, there's only a single z. I have a 5 and I have a 9. 5 and 9 is 14. And I have 3 square root to z plus 5 and another 3 square root to z plus 5. So then I have 6 square roots of z plus 5. That's equal to z plus 41. The goal at this point is to get this square root alone, so we can get rid of it by squaring. But we don't want to square when there's other stuff around if possible. There was no choice up there. All right, so to do that, we're going to have to get rid of this z right here. So we're going to subtract z from that side. Ooh, check it out. Nice. That means z minus z goes away here too. Cool. We're going to get rid of this 14. It's gone on that side. Let's reconcile, see what we got left. So let's see, that's gone. On the left, we have still a 6 times the square root of z plus 5. On the right side, the z's got rid of each other. 41 minus 14, let's see, that takes us down to 30, 27, does that sound right? Let's see, 27 plus 14 is 41, yep, okay. Next step would be to get rid of the 6. It's connected by multiplication. So that means we'll have to divide both sides by 6. Bring this up here. So 6 divided by 6 is 1. 1 times the square root is the square root. So I have the square root of z plus 5. Oops. And on the other side, let's see, 27 divided by 6. Well, for sure, 3 goes into top and bottom. 3 goes into 6 twice. 3 goes into 27 9 times. So I get 9 halves, which we could write as a decimal, but I'm going to leave it as a fraction for now. Sometimes in the online homework it says state your answer as a fraction, not a decimal. You can always switch it to a decimal later. All right, we've got the square root alone. We're ready to square again. So squaring a square root cancels the root. So now I have a z plus 5 on the left. On the other side, I have to take 9 halves times 9 halves. 9 times 9 is 81. 2 times 2 is 4. And I don't recommend mixed numbers. Leave it improper. All right, moving on. We'll subtract 5. I'm going to write the subtract 5 up here. I need a common denominator. That denominator is going to be 4, so I'll multiply top and bottom by 4, put the 5 over 1. So it's 5 times 4 is, that's 20, right? So really, 5 times 4 is 20. 81 minus 20 is 61. All right, so let's see. We got rid of the 5 by subtracting it. So I think z is equal to 80 minus 20, which is 61. Common denominator is 4. 61 fourths. All right. 4 is not a bad denominator, so I could get away with changing it to a decimal. So avoid using a calculator. This is good practice. So 4 goes into 6. How many times? It goes in once, with 2 remaining. 4 goes into 21 5 times, 1 remaining, so 15 1/4, or we could say it's 15.25. So we have 3 different versions of the answer: 61 fourths, 15 1/4, or 15.25. Now we got to check. So we're going to plug one of those versions in. Since 4 is the denominator, I'm going to go with the decimal version. It'll be easier. So copy this sucker into the screen, and we are going to check to see if z equals, once again, 15.25. Will work. So whenever we plug in, we put it in parentheses. So 15.25 plus 5, that is inside the root, then plus 3. We think that might be equal to 15.25 1 inside the root. Okay, what do we got? Oh, I'm starting to think I want a fraction version back. It's going to be hard to do without a calculator. Yeah, I don't like that. All right, fraction version was 61 over 4 plus 5. This happens in math. Sometimes you go down the wrong or up the wrong tree. All right, so common denominator. And again, the reason I'm thinking I didn't like that is if I 15.25 plus 5, that gives me 20.25. And without a calculator, I don't think I can do the square root of 20.25 in my head. Right, so this is like, not sure, dude. All right, but here, I know the square root of 4, so if I can just get at that, call that 5 over 1. We need a common denominator of 4. 5 times 4 is 20. So I have 20 fourths plus 61 fourths. And that's inside the root. That is 81 fourths. Ooh, I like this. Yeah, this is looking better. The reason I like this is now I can look at it as the square root of 81 over the square root of 4. And the square root of 81 is 9. The square root of 4 is 2. That plus 3 was just hanging out, waiting to be used. And so now I can use it. Call that 3 over 1. Common denominator is 2. That gives me 6 plus 9. Good day. 6 and 9 is 15. Halves. All right, so we got the left side down to 15 halves. So now we're hoping the right side does something similar. So we're going to view the 15.25 as the original 61 fourths plus 41. To add fractions, we need a common denominator. Common denominator is going to be 4. Scratch paper. 41 times 4. 4 times 1 is 4. 4 times 4 is 16. So I get 164. No. All right, so we've got 61 plus 164 over 4. If I add 61 to that, 5, 2, 225. So is 225 a perfect square? If this answer is to check out, it better be. So let's see, what could it be the square of? Well, if I look at the other answer, I have a clue there. I know the square root of 4 is 2. So I'm praying that 15 squared is 225. If you don't know that off the top of the head, you're going to have to check it out. So let's see. We take 15 times 15. And those of you who are reaching for your calculators, resist that urge. It's an addiction, like a cell phone. 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. Is 0. 1 times 5 is 5. 1 times 1 is 1. 5, 7 and 5 is 12. Carry the 1. Hey, it works! We did it! Holy moly! Wow, that was exciting. That was... Checking it was as hard as doing it. Okay, so what did we confirm? We confirmed that 61 fourths is the answer. Circle this sucker here. In the online system, when you do problems like this, it's either going to be 61 fourths or 15.25. Generally, you want to avoid mixed numbers. Even though they're equal, they're harder to enter into computer systems. All right. Wow, that was fun. Thanks for playing with me. Hope to do math with you soon in the future. Take care.